Hi, Russell Foltz-Smith. I'm CTO and AI biologist of Maslow AI. And what I'm talking about today is the possibilities of general artificial intelligence, in particular, an artistic process and what I call shared consequences. So, coming to agreement between different beings on what we want to do, what we want to be, and what we consider the consequences of that. I'm Russ. Uh, I'm CTO of a company called Maslow, which takes the Wolfram and the NKS stuff very seriously. I was an employee at Wolfram Alpha. I worked with my buddy Shaler here and the whole Wolfram Alpha team, getting that out the door 10 years ago. I can't believe it's been 10 years since I've been in Champaign, actually. But I decided after doing lots of other things that I would continue taking the ideas seriously, and so I've helped create a company that literally is trying to create computational beings, which may sound weird, and I hope it sounds weird, because weird is good. And so I'm going to give a little bit of an interactive talk about what I think that means and what I think we can do and what possibilities are. I want to encourage you. Everything I do is interactive, theatrical, playful. All these QR codes in the talk are active, and they go to lots of other things and lead to many places. So I highly encourage everybody to follow, go where you want to go. Everybody has a computer, everybody has phones, so do whatever you want. Even if you don't want to listen to me, but you want to read stuff, go do it. A little bit about me. I'm a occasionally random event punctuated by things that I think have meaning. You can read this. Lots of things are going on in my life, have gone on. Lots of things are going on in your life. We're all here for different reasons. Some are known to us, some are not known to us. Where computing is, where society is, where technology is. We have lots of narratives about it, but I don't know if any of us are confident that those narratives are true. And it may not necessarily be important that they're true. It may just be important that we have narratives and they allow us to keep trying things. So take this idea that I said that I take these things very seriously. I started getting NKS and computationally inspired tattoos in visible parts of my body to remind myself to keep on computing. And I mean that not just in a jokey way, but if you were at the keynote last night, and I think near the end of Stephen's marathon, I thought it was, I think he gets to the really juicy stuff at the end when you're out of steam, and this idea that he, and I certainly am devoted to it too, this idea that we need to keep giving people more capabilities. And so I'm so fascinated by how devoted he and the company and this community is to just continuing to try to build stuff. Because when you think about all the things he talked about last night, I sit there and I kind of go, what the hell is everybody doing? We don't need all this stuff. But in a way, that's what's so cool about it. It just gives us more possibility and more things to play with. And I think that's the only justification we actually need. Because again, if you go back to your own life story and you think about how you got here, it probably wasn't an obvious, easy thing. The tools that you had at the time were different than the ones that you have now. And the idea that we have all of these computational capabilities now to help us navigate our lives as we're writing the story of our lives, I think is pretty cool. And I think Stephen's right in what he said, that we are at what feels like to me too, that we're at this pretty interesting point where these capabilities are coming online so rapidly, we haven't figured out how to integrate them yet, which is something I am devoted to. So I make a big claim, and again, I'm kind of going to jump around here, but it comes together. I make a big claim about what general artificial intelligence is. Because I think the words general artificial intelligence are kind of silly words in a way, which isn't to negate them, but the idea that we're going to go chase the dream of general artificial intelligence when I don't think we have a good definition of intelligence itself. And that's not to say we shouldn't figure that out or take it seriously and not think that humans are intelligent or something like that. But it's more the point that we should keep defining what that is, which is what I think computational intelligence is. It gives us a reframing of what we might be doing and what the universe and beings in the universe might be doing. As such, why I go to an artistic idea of this is with the things you see on the screen, some of you, how many people are familiar with the three things you see on the screen? Cool. So generally these are artifacts, popular artifacts of art throughout time. We have a famous scene from Macbeth, which is where I get the title of my talk. The famous opening where the three witches visit Macbeth, and then he starts to realize that this idea in his mind of being king and all these things are going to happen may be more real than the things that are actually happening, and it takes on this life of his own, right? This is a very famous scene. It ties to my idea of what computational intelligence is, which is this idea to imagine a possibility space, to literally generate possibilities. The middle image is the famous cave paintings from the caves in France. Fascinating paintings. Should definitely look them up, because you just think about 40,000 years ago, humans like us were in caves doing these wonderful things. They think they were actually animating them using fire and the way that the light would flicker. And then the famous, This Is Not a Pipe. The real title of the painting is The Treachery of Images. I find great inspiration in this image and all of Magritte's work, because I think he was a pretty serious thinker about things, an ontology of things and what things might actually be. And this is important because when I talk about general artificial intelligence and I talk about art, I can guarantee you that we have yet to make a machine, no matter how powerful or whatever, a network of machines, the supercomputers, we don't even have a way of processing what those three images are. Like nothing. We could talk about them as images, we can compute on them, we can do all sorts of things, but in no sense will the computer ever get back to you and say, this is what this is. And to me, that's really, really important, because when you think about what you're actually doing on your computer, in what sense, when you're typing and you're writing a program, in what sense can you claim you understand what that program is? You get the essence of that program. And again, go back to Stephen's talk last night, and you think about all the things that he was doing and all the weird tentacles that went off and did stuff. In what sense could we define and reduce down Stephen's talk into a program? You can't. It was an artistic performance. He even uses the word art when he talks a lot, right? It's just, this is the art of demoing, he likes to say, I think. And it's true, because he's sort of being performative. And again, I don't mean that in a negative way. It's actually, this is important, because what he's trying to do, what I'm trying to do, is generate a shared imagination. He's trying to get us all to think, to figure out, literally just go compute and see what these tools can do for us. We're not trying to reduce down and say, this is the only way that you can compute. This is the only way that you can think about these things. This is the only space for intelligent things. This is the only possibility of these tools. Quite the opposite. So I get to put all that together and I get to a statement. I don't think anybody here is doing programming. I don't think we program computers. I think we express to them. We create a shared language with them. I think Wolfram language is a very interesting, this is what sort of drew me to it in my early career, was it was a very expressive language. It allowed me to express ideas, and now, literally in everything that I do, whether it's art or business, random projects, stuff with the school that I created, I am constantly using Wolfram language to compute things and just show and communicate. Communicate the ideas to the computer, communicate the ideas to kids or to business people, obviously using Wolfram language to communicate to you. So Let's dial it back. We kind of went way forward. Let's dial it back. So it's interesting because when we talk about the power of all that these computers can do, and we really want to, like, let's just compute and go do stuff, it's almost like a universal thing that in order to go compute, humans demand that other humans stand up in front of them and give them ideas on what to compute. And I always like to think, like, why is that so powerful? Why is it so powerful that I stand up, or Stephen, or somebody stands up in front, or you get a demo from someone, or whatever, we just get a community like this together? Why is it so powerful? Why do we need that as humans if these computers can actually do all the things that we claim they can do? There's something that's happening in this modality between people that is really critical. That if you just stare at an inert computer, is it really going to do anything? Are you going to feel like it's doing something? You're going to believe that it can do something. You're going to entrust it to do something. There's something about human-to-human interaction that I think is critical. So second thing, let's get a little weirder here. Dogs. I like to talk about dogs. I love dogs. Had dogs growing up. And when we talk about ideas of computation and intelligence and mathematics and fundamental theories of physics and pick whatever technical topic you want to talk about, I like to think about what dogs think about that. What is the experience of a dog? And why do we have no problem believing that a dog is intelligent, sentient, navigating the world, has perceptive abilities, and yet we haven't quite figured out how to talk about computers like that? And it's like, okay, well, how are you equating these things? Because again, go back to that statement where I said, we are not programming computers, we're actually expressing. I think this reframing is important. We have no problem framing a dog as having an alternative intelligence to human intelligence. They don't speak our language. I think it's fair to assume that none of us think that dogs have a mathematical theory of the universe, and yet they have no problem navigating the world. They have no problem computing. They have no problem expressing themselves. We have no problem learning how they express themselves. It is a coevolution of that expression. And just to make the point, this seems to be a good relationship and a coevolution because dog population, it's up to 1 billion worldwide. I mean, it's crazy to think, for every 7 people, we have a dog. So this coevolution is quite effective. So, again, go down a level. Why am I saying all this? Reframe it. There is no base truth or root of reality. There is, while I think Stephen is going to make interesting progress, and whoever's helping him on a fundamental theory of physics, the question I would ask is, what will that get us? When we have that theory, what are we going to do? We're going to compute. We're going to figure out what it means. We're going to go do stuff with it, because whatever this fundamental theory might be, whatever AI might be, it's not like that's the end and the universe collapses. It's not like if we invent general artificial intelligence, it's just going to think itself out of existence. It's going to make more stuff. It's going to actually paint pictures of a pipe and say, this is not a pipe, right? So my point, tie it to this thing that there is no basis of truth, and I'm not saying things aren't true, because 2 + 2 does in fact equal 4. I'm just saying there is no directionality to which truth is more fundamental. That's really important when you talk about art, when you talk about computational thinking, when you talk about being, when you talk about who we might be and what we want to become, when you talk about purpose, you don't define it. It's not as useful to define it in a direction. Instead, it's like things can be meaningful, things can be purposeful, but not tied to some anchor kind of thing. So I'm going to because I want to keep moving along here, but I'm building up a case that reframing this all is very important. These QR codes, I encourage you to visit them on your own. I use the QR codes, I'm sort of abusing them too to make a point that, what the hell is a QR code? We just sort of decided this configuration of pixels can represent anything we want it to. I don't know if anybody studied the encoding algorithms of QR codes. They're quite fascinating how weird it's been and what they actually are used for. But these QR codes remind me a lot of the elementary cellular automata, and that it's like, in some sense, we're just interpreting grids of pixels, and we sort of decide what we want to talk about when we talk about those. In what sense are these pixels not just QR codes, and there's something else, and they're bits in the system? They're artworks, they're the links behind the things. And it's like, well, why is that important to what you're saying? I go, how is a computer, how would intelligence think about QR codes? What do you think about QR codes? What actually are they? Oh, well, they're QR codes. There is no basis, track with me, there's no basis, there's no root that a QR code is tied to. It's all those things that I talked about. It is pixels, it is an image on a screen, it is encoding something else. It does spin off in lots of directions. If you do change one bit, it is no longer a QR code, okay? The way I like to tie these things together in a productive way is if there were a way to make sense of all these things I'm sort of making nonsense of, it's what I call computational adjacency. So I take Stephen's idea of computational irreducibility, take it seriously, that there are just lots of uncomputable things, and that things that are universally computable can compute all the other things, and it's like it just never ends, and like we're never going to reduce it into like, okay, we figured it out, the universe is now done. But we can use that idea and this other idea of computational adjacency to order things in the world. And what I mean by that is we tend to relate to things in the world by how similar in scope their computations are. Go back to the dog example, which is I think we relate very reliably to dogs because they inhabit the same computational space as humans. The same temperature gradients affect them, the same sleep cycles affect them, the same facial expressions, relatively the same vision and hearing signal spaces affect them in similar ways. We very much are computing in similar ways. We have adjacency, okay? Get to my next bullet point. To really pound it home, this idea that humans are the pinnacle of intelligence and that our aim ought to be to mimic human behavior, doing very trivial things like searching for memes, should indicate that it's a counterpoint to maybe intelligence also, human intelligence has strange side effects that maybe we wouldn't want to mimic in our computers, or maybe we would. Maybe a sign of general artificial intelligence is computers generate memes they find funny. Dogs are not programmed, they are shaped. So if you've never seen this video, I encourage you to watch it. This is a 20-minute history of the world. It is a hilarious video, but it is an amazing thing. Again, if you fed it into a computer, it is interesting to see what it comes back with. It cannot make sense of this 20-minute history of the world, but you can. I am trying to figure out how do we give a computer the ability to make sense of this 20-minute video. Definitely pull it up on your phone if you can. And to give you a sense, and again, I pull it up in this thing of just how crazy it is to think about reducing anything into something that we can effectively say, we've got it figured out, we have the definition, we're good, we don't need to think about it anymore. I did some calculations to kind of figure out right now on planet Earth, with the 3.5 trillion fish, the 24 quintillion microbes, these are all estimates, the 8 billion humans, the 1 billion dogs, pick all the insects. I mean, you have so many creatures around here right now, all genetic experiments, all behavioral things going on, doing all sorts of crazy things. As far as I can estimate, you have that really big number of computations going on in the world right now. And yet, so much of the aim of artificial intelligence in the industries that I tend to travel in is trying to reduce all that, trying to claim that at some point there's going to be superhuman intelligence to make sense of that. It's just not a believable claim. Yet I am claiming that we still can have general artificial intelligence. It just won't be something that reduces, it generates. Okay? People are not programmed. You see where I'm going? The theme here, it should be clear. They're shaped. We generate relationships between each other. Dogs, people to computers. So, this talk that I gave, or that I'm giving, and about to run out of time on, I actually generated 3 other talks in the process over the last month of making this talk. I'm not going to give these talks right now. These are fun talks. The middle one it will probably be of particular interest to people who wanted to be looking at code and have me demo things. There's plenty of code there where I build up the definition of a circle and then demonstrate that machine learning, our current machine learning methods, cannot actually learn what a circle is. And it's like, why is that? Just ask yourself, what is a circle? It's purely a definitional thing. There's nothing to be learned there. If you feed a computer images of a circle, you're not feeding it a circle. You're feeding it a reduced version of a circle. If you feed it a definition of a circle, what have you fed it? You can't say it learned it, you gave it the definition. So literally, I use all these fun machine learning things to generate shapes and run them through every Wolfram technology I can to see if this machine that I literally gave the definition of a circle to, can it ever resolve itself into understanding what a circle is? It can't. It's purely a definitional thing that we're doing. I could be wrong. I'd be curious if anybody goes and reads this and plays with the code to see what happens. In the third thing, I go ahead, and again, I'm going to encourage you to go get the notebook. I put it public on the cloud. I literally play with the Magritte image. This is not a pipe. And just keep recursing on the theme of this is not a pipe, ultimately letting the computer turn it into a song, a generative song about this is not a pipe. Again, using all sorts of Wolfram technology to do it. And again, only so it's like, I don't believe you can get to the truth of the matter. You can only generate with it. And the more powerful something is, the more generative it will be. The universe is not programmed. I know that many of us, I certainly have, I fall into it probably every other day. I'm like, we might be living in a simulation. Oh my God, we're living in a simulation. And it just, if that simulation is true, if we actually are in a simulation, I don't think it's because something from the outside programmed it. It's because it's generative. Reframe how we do computing. This is the way, I'm trying to give us a new way of thinking about computer. Rather than finding problems to solve, let's just keep inventing new problems. Let's just keep using these tools to grow the universe. So what are the consequences of this? What are our shared consequences now? What happens next? I'll give you what I propose as the definition of time. Time is the computational distance or difference between one set of marks and another set of marks. The time between any of us in this room is how long, how much work would we have to do to come to understand each other, to co-express. So when you sit down at your computer and you start typing away, play with this idea and think about which programs can actually map to other programs. That's the time. And why do I say time in response to consequences? Because the amount of consequences that you have to trade, the inputs and outputs between systems, between dogs and people, between computers and people, between computers and computer, it's time, it's consequences of poking and perturbing each other that we experience. That's what's actually flowing, is this computational difference. And we're trying to come closer together on this. And amusingly, this is why I love doing it. Somebody posted this on the this code base on the Wolfram community. I love doing these synonym networks. They're just so fun to play with this. And why do I like this? Because these this and that have no, they don't return anything. These are determiners. They don't have synonyms. They just are what they are. Time is in the middle of them, taking this to that. And when I plot the network of time, I'm so amused by this. These are all the different words that mean different things to time. And yet it looks like a clock, and it looks like a happy face. Anybody else think it looked like a happy face? Right? What? Think about everything I just said. This is what we're doing as humans. We are computing on so many levels of relating things we understand that you almost can't help but see that as a face and a happy face. And when I did that and I typed it into the computer, I literally was like, That's how I'm ending this presentation, because that's hilarious. And it's like, why make that decision? There's no mathematical basis for that decision other than we like smiling faces. So my pitch to you, if it's a pitch, is just to keep computing with each other. Don't do this in isolation. I've created a company that takes these ideas very seriously, and I'm literally trying to give tools to the world to help more people express themselves. I want to make computers expressible, which is why before you got in here, and I don't even care that this stuff stops, I literally just let computers run. We have a cloud set up where we just signal process. We take things in. It paints. It does nothing but paint what signals we send it. So even when I'm here, I record things and I just let everything compute and cross over, because I just believe the interesting stuff emerges from that. I think this proves, in a roundabout way, the theorem you were all coming to see proved, the infinite monkey theorem. If you let an infinite number of monkeys access to an infinite number of typewriters, they will in fact produce the works of Shakespeare, because they already did. So to me, the aim shouldn't be, can we produce the works of Shakespeare again? It's what else can we produce? What's the next Shakespeare? We shouldn't be tying our computational intelligence to the things that have already been done. We should be creating new things. And in case, now I'll kind of be a hypocrite on that, because the Rule 30 problem that Stephen is asking people to go solve for him, it's already been solved. Who's read the short story, The Library of Babel? There's a wonderful website, you can go to it. You'll find the problem statement, and if you look hard enough, you'll find the solution to the Rule 30 problems in the Library of Babel. I encourage you, if you've never read the short story, read it. And if you've never played with this website, go throw any of your Wolfram code into it. You'll find all your programs are already in the Library of Babel. It's just a search through possibility. So if you're now wondering who the hell I am, I'm an artist. I love Wolfram things. I'm an educator. I'm a coder. I'm a painter. I'm a person. I'm a computational being. That's my talk. Thank you, guys.